4.5 billion years ago, something crossed the darkness of the young solar system on a collision course with Earth. It had no name. It would only exist for a few catastrophic hours. And when it was gone, the sky above our planet would never look the same again. Picture Earth as it was back then. No oceans glittering blue. No green continents. Just a molten, restless sphere, wrapped in poisonous gas, scarred by constant impacts. This was a world still being built, still finding its shape. And on one particular day, deep in that violent childhood, a second world was quietly closing in. Scientists call it Theia, a planet roughly the size of Mars, forged from the same swirling disk of dust and rock that built Earth itself. For millions of years, they and Earth shared a similar orbit, drifting closer with every pass. Gravity does not forgive patience forever. Eventually, the two worlds met. The collision was not a scrape. It was a full body blow, delivered at an angle, striking Earth with a force almost impossible to describe in human terms. In an instant, Theia's outer layers vaporized. 1 trillion tons of molten rock and gas exploded outward into space, glowing white-hot against the blackness. For a brief moment, Earth wore a ring of fire, a halo built from the wreckage of another world. This is where our story truly begins, because that debris did not simply vanish. It lingered, it swirled, and slowly, under the patient pull of gravity, it began to gather itself into something new. Why does this story matter to us today? Because that glowing ring of destruction eventually cooled, clumped, and condensed into a single silver companion, one that has hung in our sky every single night since. The moon is not a leftover rock captured by accident. According to the leading scientific model, it is Earth's own wound healed into a satellite. Let's walk through what likely happened next, step by step, using what physics and geology tell us. In the hours after the impact, Earth's mantle, the layer just beneath its crust, mixed violently with material torn from much of this material was flung into orbit as superheated vapor and molten droplets. Within that orbiting cloud, gravity began pulling particles together, the same way a snowball grows as it rolls downhill. Scientists estimate the moon may have formed from this debris in as little as a century, an almost unbelievable speed on a geological timescale. The scientific evidence for this violent origin sits, quite literally, under our feet, and in rock samples brought home by Apollo astronauts. Moon rocks share a striking chemical fingerprint with Earth's mantle. Their oxygen isotopes, a kind of chemical signature, are nearly identical to our planet's own. If the moon had simply wandered in from elsewhere in the solar system, its chemistry should look different. It doesn't. This single detail is one of the strongest clues supporting the giant impact hypothesis. There is more. The moon has an oddly small iron core for its size. Earth's core, by contrast, is enormous and iron-rich. Researchers believe this is because Theia's iron core sank into Earth during the collision, merging with our own core, while the lighter, rocky material was the part that got blasted into orbit to eventually form the moon. In other words, we may be carrying part of another planet inside us, right now, at the very center of the Earth.
For decades, this idea remained mostly theoretical, pieced together from rock samples and computer models. Then came a discovery that changed everything. In recent research using seismic data, scientists identified two massive, continent-sized blobs deep within Earth's mantle, one beneath Africa, one beneath the Pacific. These structures behave differently from the surrounding rock. Some researchers now believe these mysterious formations could be fragments of Theia itself, buried for 4.5 billion years, hidden in plain sight beneath our feet. Let that settle for a moment. The planet that gave us our moon may not be entirely gone. Pieces of it may still be down there, in the dark, deep beneath every mountain range and ocean floor, silently shaping the very ground we stand on. Beyond the science of rocks and isotopes, this ancient collision changed the course of life itself. The moon's gravity stabilizes Earth's tilt, keeping our seasons predictable rather than chaotic. Without the moon, computer simulations suggest Earth's axis could wobble wildly over millions of years, swinging from mild seasons to extremes, capable of freezing or scorching entire hemispheres. The steady rhythm of spring, summer, fall, and winter that agriculture, ecosystems, and civilizations depend on may only exist because of that violent birth. The moon also slows Earth's rotation through tidal friction. Billions of years ago, a day on Earth may have lasted only 6 hours. Slowly, over eons, the moon's gravitational pull has stretched our days longer and longer, giving evolution more time in every rotation, more hours of daylight and darkness for life to adapt and diversify. And then there are the tides themselves. Some scientists believe the rhythmic rise and fall of ancient oceans, driven by the moon's pull, may have helped stir the chemical soup where early life took its first fragile steps. No one can say for certain that life needed the moon to begin, but its gravitational rhythm has shaped the pulse of our oceans for as long as they have existed. So the smashing of two worlds did not simply create a pretty light in the night sky. It set the stage for stable seasons, for the length of our days, for the tides that shaped coastlines and possibly nudged along the chemistry of life itself. Here is the twist that changes how many people see this story. We tend to think of the moon as separate from us, a distant neighbor, cold and lifeless. But if the giant impact hypothesis is correct, the moon is not simply Earth's companion. It is, in a very real sense, Earth's twin, born from the same catastrophic instant, made of the same shattered material, forever locked in orbit around the very planet it once nearly destroyed. Every full moon you have ever watched rise over the horizon is a fragment of that ancient violence, cooled and polished by billions of years of silence. Every ocean tide that pulls at a beach is an echo of a collision older than any mountain range on Earth. And somewhere beneath the crust we walk on, in the deep, dark reaches of the mantle, a forgotten world named Theia may still be waiting, patient and unmoving, wrapped inside the planet it helped create. We look up at the moon and see a symbol of stillness, a quiet light in the dark, but its origin was anything but peaceful. It was born from fire, from impact, from the near destruction of the world it now orbits. Next time you see it rise, remember, you are not just looking at Earth's satellite. You are looking at a piece of Earth's own history, flung into the sky, and never coming home.